Hi everyone. So we have to do a video lesson like this because I forgot that I changed the notes last year because the other ones weren't great. So I had to redo my video. I don't have access to my classroom right now. Okay, but today we are going to focus in on writing equations of lines. So we have a few different formulas we need to talk about. Again, hopefully this is a bit of a review for you. You definitely should have covered this in Algebra 1, but we all come from different Algebra 1s. We all come from different COVID experiences. So here we go. We're going to go over it. First thing, slope-intercept form is y equals mx plus b, where m we know is our slope, and b is our y-intercept. Now, if you're forgetting what a y-intercept is, it's where it touches the y-axis. Where graph touches, running out of space, the y-axis. Okay, so if we look here, it says given the graph, write the equation in slope-intercept form. So we need two things. We need our slope and we need our y-intercept. So slope's pretty easy. Remember, you count your rise over run. So how many up do we go? 1, 2, 3, 4. 4 over 2. And we know that we can reduce that to get 2. Where do we touch the y-axis? Here's your y-axis, the one that runs up and down, and we touch it right there. So how many down is that? 1, 2, 3. -3. So put it all together, y equals our slope of 2x minus 3. That's it. Okay, let's do another one. MB, our slope, how many down from this dot to this dot? 1, 2, 3, 4. So -4 because we went down. How many over? 1, 2, 3, 4, 5. Can't reduce -4 fifths, so we just leave it. Where do we touch the y-axis? This point right here, which is -2. So y equals -4 fifths x minus 2. Perfect. All right. Then we have some goofy ones, a vertical or horizontal line. Our equations are a little different. They don't quite look like that y-intercept form because we are either missing our slope or y-intercept, depending on if it's vertical or horizontal. But a vertical line is written in the form x equals a, where a represents the line's x-intercept. So remember, a vertical line goes up and down, and this line, I know it's kind of tough to see, is right here, you guys. So this line is going through our x at -1, so x equals -1. This line right here is our horizontal line. It's very similar. A horizontal line is written in the form y equals a, where a is the line's y-intercept. So where am I touching that y-axis at? It is touching at 1, 2, 3, y equals 3. Very straightforward. Honestly, the hardest part is just remembering, is it my x equals line horizontal or vertical? But just think it has to go through that axis, so it's kind of opposite of what you think. Okay, cruising right along here, running out of space on my desk in the math office. We have point slope form. Now, point slope form is an equation or a formula of the line when you're given either a point and where you need a point and the slope of the line. So it looks like this: y minus y1 is equal to mx minus x1. So m is our slope, we know that, and x1, y1 is just a random point on the line. So if we have those two pieces, the slope and a point on our line, we can write this equation of our line, which that can then be converted to slope-intercept form. Okay, so let's try this. So here is our point. So I'm going to label it x1, y1. Here's my slope, so I'm just going to put m there. Now we're just going to plug in. Ready, folks? So y minus your y coordinate of 1 is equal to our slope of 2, x minus our x coordinate of 4. So this is point slope form. We traditionally don't just leave it like this because slope-intercept form is more helpful to us when we graph. So from here, if I wanted to get y alone, that would give us slope-intercept form. I'm going to distribute that 2. And then to get y alone, we'll add over that 1. So your final answer should be y equals 2x minus 7. Okay, let's try another one. X1, Y1, our slope is a half. So we plug in y minus 4, go to our slope times x minus our x coordinate. Again, this is your point slope form, but we typically see our equations of line and slope intercept, so I'm going to get y alone. Distribute that half, so we'll have half x, half of negative 2 is negative 1. Add over 4, and we get 3. Pretty straightforward, a little algebra, but nothing too crazy, right? All right, let's flip it over, folks. Okay. We're just going to do one of these, and we'll do the other one in class together tomorrow. So this time, we have 2 points, and we need to find our slope. But we know this from yesterday that we can find slope given 2 points on the graph. So I'm going to label this x1, y1, x2, y2. All right, now we got to find our slope. So we got to use our slope formula. So that's y2, negative 1 minus 7, our y1 over our x's, y minus negative 3. Negative 1 minus 7 is negative 8. 2 negatives really becomes adding, so 1 plus 3 is 4, and we know that we can reduce that to negative 2. So now we know our slope is negative 2. I'm going to use this point right there. You could use either one, but I'm just going to use the first one. So I'm going to have y minus our x coordinate, or y coordinate of 7, times our slope, x minus negative 3. Y minus 7, distribute that negative 2. Negative 2 times 3 is negative 6. Add over our 7, negative 2x plus 1. We'll do this one in class tomorrow. Okay, and now we're kind of to the part where we can write equations of parallel and perpendicular lines. So first off, it says determine whether the equations are parallel, perpendicular, or neither. So we just have to compare their slope. So if I look at this one, the slope of this line is negative 3 over 2. The slope of this line is 2 over 3. So if I'm just focusing in on that, I do notice I have one positive, one negative, and they are reciprocals of each other. So these would be perpendicular. Yay. They are perpendicular. This next one's not quite as straightforward because I don't have this in slope intercept form, but we can easily get it there by getting y alone. So subtract over that 3x. Divide by negative 1. Okay, so our slope of this line is 3. The slope of this one is 1/3. If we look here, they are reciprocals, but one's positive. They're both positive, actually, so they're not opposite. So these would be a neither. Neither. And we will save those bottom ones to do together in class, okay? Thanks for hanging with me. Thank you for doing your part and watching this video lesson. And we will finish this up tomorrow. Goodbye.